What is principal component analysis, PC, in unsupervised learning? Imagine trying to understand a huge pile of data with many different features. It can be overwhelming to see all the details at once. That's where principal component analysis, or PC, comes into play. It is a technique used in unsupervised machine learning to make sense of large, complex datasets. Since it is called unsupervised, it doesn't need labels or categories to work. Instead, it looks for patterns and structures on its own. PCA works by transforming the original data, which might have dozens or even hundreds of features, into a smaller set of new features called principal components. These components are like new axes that help us see the main directions where the data varies the most. The first principal component captures the most variation, meaning it shows the biggest difference in the data. The second captures the next biggest difference, and so on. Each new component is uncorrelated with the others, which helps in simplifying the data without losing too much information. The process begins with standardizing the data. This step makes sure all features are on the same scale, so larger features don't dominate the analysis. Then, PCA calculates the covariance matrix, which shows how each feature relates to the others. From this matrix, it finds the eigenvectors and eigenvalues. The eigenvectors point in the directions of maximum variance, and the eigenvalues tell us how much variance each direction explains. Once the principal components are identified, the data is projected onto these new axes. This results in a lower dimensional version of the original data, making it easier to visualize and analyze. You can choose how many components to keep based on how much of the original variation you want to preserve. Often, a scree plot is used to see the trade-off between the number of components and the amount of information retained. In machine learning and artificial intelligence, PCA is especially helpful when working with high-dimensional data like images, text, or sensor readings. It reduces the complexity, speeds up algorithms, and helps prevent overfitting, which is when a model learns noise instead of true patterns. For example, in AI tools like ChatGPT or image generators like DALL and Midjourney, PCA and similar techniques are used to preprocess data, making it easier for neural networks to understand and generate meaningful outputs. It is important to remember that while PCA is powerful, it can sometimes hide important details if too many dimensions are reduced. If the main components do not capture all the relevant variation, some information might be lost. This can affect applications like content recommendations or automated decisions, where missing details could lead to unfair or inaccurate results. As AI tools become more common in our daily lives, understanding techniques like PCA helps us see how these systems organize and interpret data. It is a fundamental part of how modern AI processes complex information, making it more manageable and understandable. Knowing about PCA gives us a clearer picture of how data-driven systems work behind the scenes, helping us trust and better use these technologies.